Hello, dear students. Welcome once again into the course Particulate Technology. So, let us have the third session of the fourth unit filtration in today's class. So, as we usually do, let us just briefly go into the topics which we learned in the last class. So, we in the last class we discussed about the characteristics of filter medium. So, we learned about filter rates. So, what role a filter rate plays in filtration? So, what are the types of filter rates that we use and how we can use the filter rate? So, all this we discussed. So, then we discussed about the various factors that affect the rate of filtration. Then we learned the classification of filters that are used in industries, and also we discussed about the various factors that are to be considered while selecting a suitable filter for the given filtration duty. So these are the topics that we are going to discuss in today's class. So here we are taking up one type of filter, that is sand filter, to study its construction and working principle, and also the application and types of sand filters. So under the different types of sand filters, we have a rapid sand filter and pressure sand filter. So let me teach you about the construction and working of these types of sand filters. And then onwards, after that, we are taking up industrial pressure filters, understand their working principle generally, and see their advantages and disadvantages. The sand filters are that deep bed type of filters, so which are also called as clarifying filters, which are found useful in water treatment or water purification process. So you all know what is the principle of operation of a deep bed filter. So in the filters in which the filter medium will be in the form of a deep bed, so which are basically used for separating uh, small quantity of solids present as a suspension in liquids. So they are also called as clarifying filters because they are used for producing sparkling clear liquids by removing suspended solid particles from them. So these are the types of filters that are usually used in water treatment and water purification. The filter medium, as I said before, is in the form of a bed of sand particles of varying grades. So this filter clarifies the water to produce sparkling clear water by filtering out the suspended solid impurities. So whenever the sand filter also need to be designed to remove unwanted odor and taste from water, so then along with the bed of sand particles, you require an additional layer consisting of a bed of activated carbon particles. So activated carbon particles act as adsorbent particles, removing those substances present in water that is causing unwanted smell and taste. So that is all about the introduction to sand filters. So this is a list of the different types of sand filters. So we have a gravity sand filter called as a rapid sand filter, and there is a slow sand filter and a pressure sand filter and the upflow sand filter. So among these, let me teach you in detail about the rapid sand filter and pressure sand filter. So first we are taking up the rapid sand filter. So this figure shows the constructional details of a rapid sand filter. So it basically consists of a rectangular tank which is open at the top. So then the filter medium will be present in the form of a bed of sand particles that is supported on a bed of gravel, and below that you have a discharge system consisting of a central pipe connected to a number of lateral pipes which are perforated. So this is a type of drainage system that we have at the bottom of the sand filter to take out the filtered water and also to pass the wash water in the upward direction. So we have a trough kind of system here to feed the water that is to be clarified in the sand filter. So it is a gravity filter, means the water flows under the influence of gravity from top to bottom and is a widely used filter in the treatment of water. It consists of an open tank, as I said, which is watertight, means constructed in such a way that there is no leakage of water from any part of the tank, having a depth of around 3 to 3.5 meter and containing a filter bed which is made out of a layer of coarse sand particles with a thickness of around zero point 0.6 to 0.75 meters, and the size of sand particles are in the range of zero point 0.4 to 1 millimeter size. So that is how you can construct a sand filter. The sand bed is supported on a layer of graded gravel. So this is a layer of graded gravel particles in the size range 1 to 50 millimeter. So having a thickness of 0.45 meters. So below the gravel, as I explained you, so there is an under drainage system consisting of a central longitudinal conduit or manifold. So this is a central pipe connected to the smaller lateral pipes. So with strainers mounted on top. So there is a strainer, means a filter mounted on the top of this drainage system, and pipes of smaller diameter called laternals. So these are the small diameter pipes called laternals. So that carry perforations on the sides and the bottom. So that is a drainage system that is incorporated in a rapid sand filter. The water to be filtered is introduced from the top and flows downward through the bed of sand particles. So these are the troughs used for water. They're feeding the water that is to be purified. The water enters into this trough, overflows, and then it drops on the bed of sand and flows through the bed of sand and then through the bed of gravel. So finally coming out at the bottom. So where they are carried away by this drainage system that is provided at the bottom. So after a bed is used for a certain period of filtration, so the bed will be filled with the separated solid particles. So then we need to provide a backwashing. So that is done by using or by passing the backwash water from the bottom to the top. So the filter bed is periodically cleaned by backwashing. So during backwashing with water, the upward flow carries the deposited flock with it. The essential characteristics of rapid fire sand filters are like this. So we can obtain a high rate of filtration in this one. So cleaning can be easily done with the backwashing, as I explained you just now. So careful pre-treatment of water is necessary in this kind of filters. So let us now take up the pressure sand filter. In this kind of sand filters, water is filtered through a filter bed under a suitable pressure. So this is a high pressure operation compared to the previous one, and the filter medium is contained in a steel tank. So since this is a high pressure operation, the filter medium will be contained in a solid steel tank. The precious filters are commonly used for the treatment of boiler feed water. That is, the water that should be fed to boiler to produce steam should be free from all kinds of suspended solid particles. To remove those particles, these particular type of filters are used. The water, instead of gravity fed, is pumped through the bed under pressure. So you need to force the water through the bed of sand particles. So these units are built as vertical or horizontal units. So either you can have a vertical tank or a horizontal tank. So the former, that is a vertical tank, um, is used for relatively small amount of water, while the horizontal kind of construction can be used to handle a greater volume of water. Pressure sand filtration is often carried under coagulation and sedimentation. So that means we need to add coagulants and carry out sedimentation. So in order to remove the finely divided particles. So you all know what is coagulation. That is whenever the particles present in a water are finely divided particles, so the settling of such particles will be very difficult. So what you can do is you can add coagulating agents or flocculaging agents such as aluminum sulfate, so which react with water forming aluminum hydroxide, so which is a highly adsorptive precipitate. So that adsorptive particles will cause the agglomeration of the very fine particles to form flocks. So those flocks being heavier and greater in size can be easily removed in a filtration or a sedimentation. So if that cannot be done, so what you can do is you can add the coagulants to the filtered water pipe ahead of the filters. So whichever pipe that is carrying the water to the filter, so into that pipe we can add the coagulants. So by the time the water enters the filtration filter, the coagulation would have taken place, so that the formation of flocks has already taken place, and the flocks gets retained inside the bed when you pass the water through the filter bed. That is how we can carry out simultaneous coagulation and filtration in sand filters. So the pressure of feed can be up to 2 to 5 bars in these types of filters. So the dimensions of pressure sand filters will be like this. It can have a diameter of zero point 0.5 to 2.5 meter and height of around 2 to 2.5 meter if it is constructed as a vertical tank. So while the horizontal tanks can be constructed with a diameter of around 2.5 meters and the length can be up to around 7.5 meters. So the advantage of pressure sand filter over rapid sand filter is that so these occupy less amount of space to give the to handle the same capacity of water. So that is the advantage of pressure filter over rapid sand filter. Now let us take the discussion to industrial filters. So there are different types of industrial filters based upon different types of driving forces, as you all know. The filters which operate with the super atmospheric pressure on the upstream side of the filter medium and atmospheric pressure or a slightly greater pressure on the downstream side of the filter medium are called as pressure filters. So basically pressure filters are those filters which use pressure force as the driving force for the filtration operation. So they employ a pressure of greater than atmospheric value on the upstream side of the filter medium and maintaining an atmospheric pressure or a slightly higher pressure on the downstream side of the filter medium. So such filters that are used in industry are called industrial pressure filters. So for example, we have a filter called plate and frame filter press and a leaf filter which is employing higher pressure as the driving force. So are the examples of pressure filters, industrial pressure filters. So these are used by applying filtering pressure, which is higher than the atmospheric pressure on the upstream side of the filter medium by using a liquid pump or by a compressed gas. So pressure filters, since they are operating at a higher pressure, have to be fed by a plunger, screw, diaphragm or centrifugal pumps. So you need a suitable pump for introducing the slurry to the pressure filter. So the drawback of the pressure filter is that it is not that easy to discharge cake whenever pressure filters are to be operated in a continuous manner. So pressure filters are mostly batch operated because it is very difficult to discharge cake from a high pressure environment. So that is a limitation of a pressure filter. So let us now just go through the important advantages and disadvantages of pressure filters operated in industries. So since we are using high pressure in the operation, then we can expect the rate of filtration to be rapid. So these are the compact devices. So they can provide large filtration area per units amount of space occupied by the filter. So for the same amount of filtering space, pressure filters compared to gravity filters can give you large surface area that can be used for filtration. So pressure filters, when operated in batch-wise manner, offer greater flexibility than any other type of filters that we come across. So also the initial investment for such kind of filters is very low compared to other types of filters. Coming to its disadvantages, it cannot be adopted for a continuous process. So because as I already told you in the previous slide, that the discharge of cake from pressure environment is not that easy. So if it is operated in a continuous manner, then the cake also has to be continuously removed. So because of that difficulty, they cannot be that easily adopted for a continuous process. And also operating cost will be high in many applications. Okay, so when they are operated in a continuous manner, they are quite inflexible compared to other types of filters. So these are the disadvantages of pressure filters. Okay, so this is just a set of YouTube links that help you watch the videos showing you the working of the animation of working of various sand filters. So this is a recap of today's class topics. We learned about sand filters, the different types of sand filters, their construction and working details, and we discussed briefly about the industrial pressure filters, their general working principle, or what are their advantages and disadvantages. So let us have a self-assessment test now. These are the MCQs of today's topics. For clarification of potable water, we use a dash filter. So whenever water purification comes up, so it is always a sand filter that is widely used. So let us look at the options: gravity sand filter, plate and frame filter, vacuum leaf filter, then rotary vacuum filter. Okay, sorry, here this word MCQ has come up by mistake. So the option D is just the rotary vacuum filter. So plate and frame filter press, vacuum leaf filter, then rotary drum filter are all the industrially operated filters. So they are suitable for industrial applications. So for purification of drinking water, the sand filter is the right kind of filter. So option A is the answer for this question. Filtration of water in a paper mill is done by using a dash filter. Is it open sand filter? Is it plate and frame filter press? Vacuum leaf filter, sparkler? So sand filter is the one wherever you require to purify water. So filtration of water is usually done with a open sand filter in a paper mill. Okay, so these are the MCQs that are related to the topics that we discussed in the previous class. So in the previous class, due to the shortage of time, I could not take up this one. So let us just go through in the present class. So filter rate is used to, the options for this MCQ is increase the rate of filtration, decrease the pressure drop, increase the porosity of the cake, act as a support base for the filter medium. So you all know that filter aid is that substance that is added to the slurry in order to increase the porosity of the cake. So in whichever situation A cake is formed in the form of a dense impermeable cake, that is a compact cake, so which has a minimum porosity. So you can use the filter rate to increase its porosity so that the flow of filtrate through the filter cake will not be that difficult. So the option C is the right answer for this question. So filter medium resistance is the one that is offered by options: filter cloth, particles trapped inside the filter medium, filter cloth and the particles entrapped collectively, or none of the above options is correct. So which option according to you is the right option? Okay, so whenever the liquid has to flow through the filter, it faces many resistances. Okay, so the main resistance offered in a filter to the flow of filtrate is the resistance offered by the filter medium and the cake that is deposited on the filter medium. Okay, so before the formation of a cake, so whatever the resistance that is posed to a flow of filtrate is the filter medium along with the particles that are trapped inside the filter medium. Okay, so whenever the filter medium resistance is said, it is the resistance offered by the filter cloth as well as the particles that are trapped inside the filter cloth, because once the particles get entrapped inside the filter cloth, so that combination acts as a filter medium for the rest of the filtration process. So it is the resistance offered by the collective, that is a combination of the filter cloth as well as the particles that get stuck inside the filter medium. So option C is the right answer. So the most common filter aid is, okay, so let us first take up the third question. A compressible cake has maximum porosity at the upstream side, maximum porosity at the filter medium, same porosity throughout the cake thickness, none of these. See, compressible cake has a tendency to form a cake that compresses tightly and forms a bed of very less voidage, that is bed of less porosity. Okay, so at what location for a compressible cake the porosity is high? So that is what you have to decide to answer this question. So whenever a cake having a tendency to form a compressible cake is getting filtered in a filter medium, so initial layer of the cake so will be the one which will have a less amount of porosity, because at the beginning since the high pressure is acting on the filtration, so because of the high pressure and the high rate of filtration, the initial amount of layer solids that are packed tightly on the filter medium will have the minimum porosity. So the option A, the maximum porosity on the upstream side, means the top side of the cake. It is saying that there is a maximum porosity on the upper face of the cake. So this is not true, because the upper layer of the cake is the one which has formed later. So whatever the layer of the cake that has formed right above the filter medium is the one that is having the minimum porosity. Okay. So the layer of cake having that is facing the filter medium, that is right above the filter medium, will have the minimum porosity. So option B is incorrect. So obviously it will not have the same porosity throughout the cake thickness, because uh, as I already mentioned, the layer of solid that is initially deposited on the filter medium will have the minimum porosity. So option B and C according to this discussion is incorrect. So our option is option A. So the maximum porosity will be on the upstream side of the cake. The most common filter aid that is used in the industrial filters is it diatomaceous earth? Is it calcium silicate? Is it sodium carbonate? Is it silica gel? So when we discussed about the filter aid, so we saw some of the examples of filter aid. So among which I said diatomaceous earth is the very commonly used filter aid. So option A is the answer for this question. So gelatinous solid which are capable of plugging the filter medium can be filtered by a dash filter. So let us see the options: sparkler filter, platen frame filter, vacuum leaf filter, pre-coat filter. So gelatinous solids, as already mentioned here, are capable of plugging the filter medium, which is a not desired process. So in order to prevent this solid from plugging the filter medium, from making the filter medium blind, so what we can do is we can use a layer of filter aid on the upper side of the filter medium. That is the upstream side where the slurry is admitted. So you know that there are different methods of using filter aid. So one of the method is pre-coating the filter medium with a layer of filter aid. So gelatinous solids are better handled by a filter that is having a pre-coated filter medium with a layer of filter aid. So option D is the right answer for this question. So this question is already come up in the previous slide. Diatomaceous earth is a dash. Is it an explosive, filter aid, filter medium, catalyst? So I hope all of you have got the right answer. Option B is the right answer. So diatomaceous earth is a common filter aid used in industrial filters. Which of the following is not a continuous filter? Platen frame filter press, rotary drum filter, leaf filter, none of these. So not a continuous filter means the batch filter. Which among these is a batch filter? So under the classification of filtration, so we saw platen frame filter press being mentioned in the category of a batch pressure filter. So option A is the right answer because rotary drum filter and leaf filters are usually the continuous type of filters. The flow rate of filtrate in a constant pressure filtration continuously decreases, continuously increases, remains constant throughout, may increase or decrease depending upon the pressure. So which among these four options is your choice? So in the beginning class we discussed about the constant pressure filtration and constant rate filtration. So according to that discussion, the constant pressure filtration is the one in which the pressure drop across the filter medium is held constant by applying certain inlet pressure and maintaining it throughout the run so that the rate of filtration which is maximum at the initial stages will continuously decrease till a minimum is reached. So continuously decreases comes in the second option number, that is option B. So option B is the correct answer for this question. So that's all for today's class. So thank you for being a part of the session. So let us again meet in the session number 4 of filtration. Till then, bye.